The LG Indoor Mini Split Air Conditioner circuit board, which has a specific number that you can see on the screen, is completely dead and not turning on at all. It seems that someone previously tried to repair it, but wasn't successful. The camera image is unclear, but it looks like someone attempted soldering and worked on certain points, but did not fix them properly. So now, we are trying to determine whether we can fix it or not. In many videos, I often say that the first step should be to physically check the circuit board to see if there is any damage. It is especially important to check if someone has previously worked on it. Then, checking the physical condition of the circuit board is really important, as sometimes people miss reinstalling parts or forget to put everything back together properly when returning the circuit board to the customer. If you don't check the circuit physically for any damage, it will be very difficult for you to repair. Now, if I look at this circuit board physically, I've already shown you from the backside that this circuit board has been repaired. When I am touching this capacitor, it seems to be loose and has disconnected from its place. This is a problem, and when I check it from the back, I see that the prints of this capacitor are damaged and separated, which indicates a fault. Additionally, an NTC sensor appears to be damaged. Until I check the NTC sensor, I won't be able to understand the issue, but it looks like there is internal damage. Other than this, I don't see any other physical damage at the moment, but testing is crucial. Now, for testing this NTC sensor, I have set the multimeter to the ohms mode. The NTC is written on these 2 points. I have attached multimeter probes with the NTC sensor, which show a resistance of 16.72 kiloohms. Also, I found another point where a CO2X capacitor seems to have a short circuit. It has turned a bit black, indicating a fault. This suggests that there was an issue with electricity fluctuation or a similar problem. Moreover, there is a bridge rectifier, which is very important. If this also has a short circuit, it will contribute to the issue. We will need to check it by placing the probes and testing it. Look, the positive is marked here, so we will place the positive probe on the positive point and the negative probe on the negative point. The negative is on that side, sorry. So, I'll first check with this pin. Now I'll check the next pin. Now I'll check the reading on the negative pin. There's no reading showing on any of the pins. We are not getting any value at any point. It might be possible it is fine. However, first, we will change the polarity of the probes. I will place the negative probe on the positive point and the positive probe on the negative point. Here we see 0.501 voltage drop on the multimeter. Similarly, if I place the probes on the second point, 0.508 voltage drop is present. Now I will place the probe on the negative point. We are seeing the same voltage drop. When we change the NTC sensor, we will also need to change this rectifier as well. If we don't change it, sometimes it seems to be working fine, but internally it might start leaking or cause issues again. The best practice is to change it to avoid future problems. Now similarly, let's test the capacitor here. I will set the multimeter to continuity mode. Now let's check it. You can see that this capacitor is completely short-circuited. Even if we change the other components, our PCB won't turn on. You can still hear the sound indicating a short. So first of all, we need to remove this capacitor from here. The capacitor has come out of the circuit. I will remove this NTC sensor from the circuit as well. The NTC has come out of the board. Earlier, we could see it from a distance, but now it is clearly visible that it is damaged. Either it experienced a voltage surge or a spike, as it is installed in the system to control spikes. If any kind of spike occurs, it will get damaged to protect the rest of the PCB. Now let's remove the bridge rectifier as well. You can see BD01J written here, which indicates our bridge rectifier. We will remove it from here. It's almost out now. And finally, it is out of the circuit. Next, I'll check if anything else is damaged here. I will switch the multimeter to diode mode to check the diodes. Look, when I place the multimeter probes on it, it's not showing anything. We will change the polarity of the probes and check again. This diode is fine. Just like this, there is a resistor above it, and below it, you can see a Zener diode. Let's check it as well. I place the probes here, and it's showing 0, which means it could be faulty. So, let's switch the polarity of the probes. It's still showing 0, indicating that it's faulty. Similarly, I will check all the points of the SMPS. Look, there's another diode here. Let's check it as well. It's showing a voltage drop of 0.479. So it's working fine. This capacitor is causing a lot of trouble, so let's remove it. I have removed the capacitor, and it should be fine because these usually don't fail. The diode I showed you is also short-circuited. I will remove it from the circuit. First of all, I am adding solder to it. The capacitor that was short-circuited was attached on top of this Zener diode. The Zener diode is out of the circuit. If we look at the number of the Zener diode, you can see it's labeled BZX, and here it says 85C. This is its number. The complete number of the diode is BZX8568. Let's check if this Zener diode is working or if it's faulty. On checking with the multimeter, it shows that it is indeed short-circuited. The reading is showing 0 voltage drop, so it is completely shorted. Now, all the components that I removed, I will add new ones in place of them. I have a diode here whose number you can see. It's BZY97C100, which is approximately a 100-volt Zener diode and is 1.5 watts, so I'll go ahead and install it. It's important to be very careful about the polarity because if the polarity is incorrect, it will short circuit within a minute. I've installed it and the polarity is correct, so there's no problem. Now I'll install the bridge rectifier as well. The polarities are very important here because if you install them incorrectly, everything could blast within a second. It's done now, so I'll secure the pins from the back side by tilting them so that it won't go out. Similarly, let's install the NTC thermistor. That's done too. Now let's solder everything. Soldering with paste works really well, but I'm working without paste, so it's a bit difficult. Without paste, the soldering isn't coming out well, so I'll add a little bit of paste here. You'll see that the joint will be much cleaner with the paste. Now it's perfect. I'll also add paste here, as it helps a lot when soldering. You can see that now the soldering is proper. I'll solder all 4 points as well. All these 4 points are soldered. Next, we need to solder the capacitor. To solder it, we need to clean the prints underneath it. If the prints are not visible, we won't be able to solder it properly. It's clean now, so let's clean the other side too. Finally, I'll install this capacitor here. Now that the capacitor is in place, we'll solder it. I will tilt its pins, and let's solder it from both sides, and the soldering is complete. And now only this capacitor is left. This capacitor is 100 nanofarad and approximately 25 volts. Since I have a slightly larger one, I'll use it because I don't have the exact one right now. The capacitor is very important here because it controls spikes, but the larger one should work for now. The circuit board is now completely ready. Let's plug it in and see if it turns on. It has turned on, so I'll try to turn it on with the remote, but the remote isn't working properly. I'll try with the on-off switch, but it's not turning on either. Let's check if something is getting hot. No, everything seems normal. Since everything is normal here, let's plug it back in. I've plugged it in and turned on the switch. I've set the multimeter to DC voltages. Since we heard a sound, that means the PCB is on, or it turned on and then turned off again. To confirm, let's check this side. There's a voltage regulator here, and it's supposed to be a 5-volt regulator. Let's check if we're getting any voltage here. The center pin is the ground, and we can check on either side to confirm. On this side, we're getting 12.26 DC volts, so this is the input for the voltage regulator. Now let's check the other side to see if the voltage regulator is generating 5 volts. Yes, it's generating exactly 5.4 volts, so our SMPS is working properly, but the display isn't turning on, and neither is the remote. When I thoroughly checked the circuit board, I realized that physically checking for damage is crucial. Let me show you why I'm saying it. Here, you can see that the PCB is broken. Because of this breakage, I think the prints underneath might be damaged. If we look closely at this PCB, we can't see the prints from this side of the circuit board. If we normally look at the circuit board from either the front side or the back side, the prints become visible. But here, the company has double-coated it. There is a green color over the prints already, but a light green color has also been applied to the layer with the prints. Because of this, all the prints have disappeared, and it's hard to understand where they are going. However, when I slightly cleared the area, I could see the prints underneath in this position. I can see that the print on this PCB appears to be broken. Normally, if we look at this PCB, it seems like there are no prints underneath. However, since the circuit can't be interconnected without these prints, the company might have done this either to mislead or perhaps as part of a new strategy. You can see here that the print seems to be broken at 1 or 2 points. This might be the reason why the display and the remote aren't working. We need to clean it further to get a clearer view. Yes, the prints are indeed present underneath. Now, we'll need to trace them to understand which print connects to which component. You can see that the last print is missing from this point. It's broken. Moving forward, you can also see that another print is missing. This means these two were connected to each other. The other prints appear to be in much better condition, and I don't see any issues with them. If we look at these prints, it seems to be leading toward the display. This suggests that the display might not be receiving the necessary voltage, causing the problem. I'll connect a wire here, but first we need to set the wire properly. Setting the wire correctly is crucial because it will make soldering easier later on. I will use UV masking for this. The color we have is almost the same as the original. Let's open it up. We'll apply the paste here, and similarly on the other point as well. This will make our work easier. Now we'll straighten the wire and attach it here, and then we'll place it on top of this. I'll use a UV light on it, and then I'll lower it. It's almost dry now. I'll bend the wire and attach it to the other side. I am adding some solder mask here as well to make it tighten. Once it's done, I'll apply UV light to it again so that it sets quickly. I think it's done now. I will turn off the UV light. I will apply some paste to this wire. Once the paste is applied, I'll solder it so that when we place it underneath, it will be easier to work with. The work is complete now. You can see it's all clear. First, I'll solder this wire because soldering it is very important. If we don't, the work won't be done properly if we don't apply the flux. Look, this wire is unnecessary, so we'll cut it off from here. You can see how much benefit we've gained from using masking. I'll follow the same procedure. I'll attach one probe here and move the other probe to this point. You can see the continuity is now complete at this point. It's perfectly okay. In fact, it's connecting at 2 or 3 points, so our work is done correctly. Now I'll apply masking again on these 2 points, which is very important. If we don't apply it here, it could break again. I'll fill it up so that it becomes stronger. Once it's secured with the points, the work will become easier for us. I think that's enough. Now, let's try turning it on with the remote. The remote is working, and as you can see, the display has turned on. It started working, and let's also check the buttons. It's turning off and on, as you can see. That's why I often say that physically testing the circuit board is very important, because you can find faults physically. If I had ignored the physical check, the PCB wouldn't have been fixed. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.